Hello, my name is Claire Bailey, and this is my project on how honeybees continuously retract the edges of their comb following nest expansion. When a swarm of honeybees, or Apis mellifera, locates a place to live, they immediately get to work and begin to construct sheets of comb to store their nest resources. To do this, they have to produce wax scales from their abdomen, which are energetically costly. It takes around 7 pounds of honey to make a single pound of wax. As the nest grows, the bees will add more hexagonal cells along the edges of constructed comb. Honeybees will do this until they fill their cavity with comb, and since the bees can't consume this wax, it will remain in the colony for life. Here is an X-ray microscopy image of a segment of comb mid-construction from Franklin et al.'s 2022 paper on comb construction. This highlighted section shows what I will call the leading edge, which is also noticeable in newly built comb. This leading edge acts as a growth front, where new cells will be added over time. Our lab developed an assay to evaluate 3D nest construction and track comb growth over time. This involved weekly colony inspections, where we took pictures of every bee frame in the 5 colonies using this photography rig. This gave us 1,800 pictures, which we simplified to give us information about area and comb shape. We looked at these images over time to see how the bees built their nest as the colony aged. Looking at our data, it was obvious there was initially a lot of comb growth, but then the area seemed to even out and stabilize after reaching a maximum comb area. Looking more closely, it looked as though the total comb area had decreased, which we initially thought was some sort of error. All 5 colonies in the study experienced comb area decrease, and 96% of individual frames decreased as well. Our median comb area decrease was about 40 millimeters squared, with as much as 60 millimeters squared decreasing in a single frame. This graph shows the percentage of comb decrease from the maximum, and the median decrease was about 3%, with several frames experiencing a 4% decrease in the total comb area. I was curious where exactly the comb shrinkage was occurring, so I looked at frames that experienced the largest decreases and overlaid the images to see what parts of the comb changed. I found that the comb along the leading edge decreased after the colony stopped growing, so the honeybees would rapidly construct comb during a building phase, reach a maximum comb area, and reduce this leading edge during their mature age. These changes were minor and occurred over many days, but the morphological differences in growing versus mature comb were noticeable. Here we have 2 different pieces of preserved comb, one from an actively growing colony and one from a mature colony. Looking at the comb laterally, we see that the leading edge extends further in the growing comb, while in the mature comb, the leading edge is less visible and does not protrude as much. Viewing the comb from beneath, we see that there is excess wax on the growing comb, and in the mature comb, this wax has seemingly been trimmed back. Lastly, we took a cross-section of each piece of comb using a hot knife, and we can see that the growing comb comes to a sharp point, while the mature comb has been smoothed over and rounded along what once was the leading edge. For the last aspect of my results, I wanted to know if certain colony factors affected the amount of comb that was reduced. I found no significant connection between comb reduction and the perimeter of comb, the comb area, whether the frame was in the center of the nest or on the edge, or the distance from the entrance. So our results tell us that there is a decrease in total comb area and that reduction happens when a colony stops growing. This reduction was ubiquitous and continuous for all of our colonies. While looking at a colony not included in this data, I observed the addition of a leading edge, following a mature phase. This raises questions about when bees rebuild the leading edge and if it is used to trigger comb expansion or some sort of secondary growth. Future investigation will look more into this, as well as focusing on how honeybees reduce their comb and where they relocate their wax. It is counterintuitive that honeybees would shrink the size of their comb given their investment in something as costly as wax, and considering their frugal practices within the colony. Honeybees only build comb when it is necessary, like when they're initiating their new home. So why then are they removing wax during stable, non-growing periods within the nest? Could they potentially be repurposing this wax for other colony tasks? How might these minor comb alterations impact the colony? I hope to answer these questions as I move forward in my research on honeybee nest construction. I would like to thank everyone at the Smith Bee Lab with their help on this project, and hope to answer any questions or comments people might have. Thank you for your time.